So hello everyone and welcome to my talk today about my little hobby tool Lucene-grep, also known as LM-grep as I call it. First of all, I want to thank the London Information Retrieval Meetup organizers for accepting my proposal, and I want to thank all of you for joining me in such a nice summer evening. So let's begin. So who am I? My name is Dainius Jocas. I currently work for a company called Vinted, whose mission is to make the second hand the first choice worldwide. My role there is a staff engineer, and my responsibilities are mainly to look over how the search applications are being developed. So I work with search engineers there. I do have some online presence. I do have my personal website where I blog from time to time. I have a Twitter. I do have a GitHub, and since I do like very much open source, I also contribute, and I do have a couple of my own tools, namely Lucene-grep and Cat. So yeah, what's for today? So at first I will introduce what I'm going to talk about. Then we'll talk about what's inside the Lucene-grep. What does this little tool has? Then I'll talk about a couple of use cases which I'm currently using it and my friends are using it for. Then I'll talk about a couple of future work directions for the Lucene-grep, and then at the end, I hope that we will have a couple of questions and we'll be able to have a nice discussion then. So yeah, let's begin. So what is this Lucene-grep thing anyway? So Lucene-grep is a command line full text search tool. It's at the very surface, it's very similar to what grep does. However, it's based on Lucene, on Apache Lucene, and the Lucene monitor library is the main building block of a tool. This command line tool is made with GraalVM native image for ease of distribution and reduced requirements for resources. Therefore, it's a single binary file. You just download one file, no external dependencies, and this tool supports most of the operating systems there, namely Linux, macOS, and Windows. This Arch64 is coming. So yeah, that's that. So how come that a new search full text search tool appeared in 2021? So the origins of the Lucene-grep. So some time ago, when I was an NLP consultant, I used Elasticsearch Percolator for some basic named entity recognition because Elasticsearch was always there, and the Percolator did exactly what it needed to be done. So, but then came a project where the client asked me to deploy the same named entity recognition solution on AWS Lambda. And Elasticsearch was not an option there because everything had to be serverless, etc. You know, the hype cycles. So, however, I really like the idea of expressing entities. Entities meaning company names, company titles, person names, stuff like this, as a full text search queries, because it allowed me to do cool stuff with it. And then given that project, I was looking around, how can I continue with this entities as full text search queries? And I discovered a little library called Luwak at that time. And then it did pretty much the same as Elasticsearch Percolator was doing. So I just took it, deployed it into AWS Lambda, and it worked fine. However, it ran as a JVM in the AWS Lambda. And within JVM in Lambda, you have those bad things like a cold startup problem, and it's relatively hungry in terms of resources. So sometime later, about half a year ago, on the internet, I discovered a blog post by Gunnar Morling, the Red Hat software engineer, who blogged about a trick that he did, which was he deployed the search of his personal website on AWS Lambda, and the search was backed by Lucene, compiled with GraalVM native image. I was excited. Ooh, So now it's possible to compile Lucene-based projects with GraalVM native image. So I looked it up. It looked okay. It worked on my machine, which was very important at that time. And so I've moved on and convinced a couple of other Red Hat engineers that they should open source this trick of that allows Lucene to be compiled with GraalVM native image and release it on Maven Central. So that's how the Quarkiverse Quarkus Lucene extension was born. And then when it was done, I hacked Lucene-grep. So what's this Lucene-grep? So as you see from the name, grep, and here's grep. So basically what grep does, it searches for a substring in some other string. Like here, I have a string, Lucene is awesome, and I grab the string with the query Lucene. And it finds that this text, this line particularly, matches the query, and then there's an output. And as I've said previously, Lucene-grep on the very surface does pretty much the same thing. So I have my text, Lucene is awesome, and I ask lm-grep to search for Lucene, and it happily does the work. And the output is pretty much very, very similar. It highlights the part that matched the query and where it found this queries. In this example, it was standard input. So Lucene-grep does pretty much the work that grep is promising to do. Yeah, cool. So if you are interested into trying it out, it's not very complicated to do since it runs on all the platforms. And here are instructions on how to get it running. You can go to GitHub repo of the Lucene-grep, but basically for Linux and macOS, you can use brew and install it. And if you're running on Windows, you can use scoop to install it on your machine and have fun with it. Yep. So what's inside the Lucene-grep anyway? So what are the building blocks there? So as with grep, it knows how to read from files. It knows how to search for files with the glob pattern. Glob pattern is such a thing like in this example here, like in all the descending folders where the suffix of a file name is .txt. It knows how to read the text from the standard input. It knows how to write the output of a search into standard output in various formats, which we'll see later on. For example, it can write the output in JSON. And then the main building things of the Lucene-grep. So Lucene-grep has a nice way how to construct the text analysis pipeline on the components that are provided by Lucene open source project. Lucene-grep also supports multiple query parsers. As a neat trick, Lucene-grep exposes a flag that allows to see what kind of tokens this analyzer produces given some text. A thing that makes Lucene-grep a bit different from grep is that it can run multiple queries at the same time. So that's cool. And Lucene-grep does full text search, which grep is not doing. However, I can go on with this little feature set, but if you downloaded it, you can just run lm-grep -h, and you will see a full list of options provided. So let's talk about what's inside the Lucene-grep. And the first thing which I would like to speak first is about text analysis. So the text analysis is the same text analysis of Lucene. And the last release of Lucene-grep had embedded inside 45 predefined analyzers available. Most of the analyzers are something like Lithuanian analyzer, meaning analyzers for a specific language, but there are others. It has 5 character filters available, 14 tokenizers, and I was surprised when I've seen that number, 113 token filters. Yeah, so these are the numbers. However, not everything that Lucene provides is available in Lucene-grep because of limitations of GraalVM native image compilation. But if you want to take a look at what exactly are the token filters available, you can go to the GitHub repo, open the docs folder, and then there's a documentation page for analysis components where everything is listed. So that's that. Okay, so what's the trick about this text analysis thing? So when I first hacked the Lucene-grep, I exposed a couple of flags for text analysis. For example, there was what stemmer should I use? Should I use the English stemmer or should I use German stemmer, etc. However, it was very limiting in terms of what kind of analysis pipeline could be built out of those couple of flags. And the biggest problem was how to expose ordering of, let's say, token filters in the analyzer chain. So, and the biggest problem is that Lucene is, as you know, a Java library, and Lucene analyzers are basically Java classes. And for a command line tool, exposing Java classes is not a good option. So, but however, I wanted to have something similar what Elasticsearch analysis, the index setting analysis part provides, something similar like data-driven. And then one day I came up with a solution that that allowed to express the text analysis with a declarative way. And it was data-driven, meaning a simple JSON file where I specify things such as a list of char filters, I specify tokenizer, and I can also provide a list of token filters. As you see, it's an array, so the order is important on by which they are applied, and then these analysis components, as I call them, can have their own arguments to customize this particular analysis component. So this is most likely the thing that I'm most proud of about this Lucene project, and I believe that it would be worthwhile to release a library that, as a standalone library that would mimic this behavior of specifying Lucene analyzers with the simple JSON structures. Yeah, so that's about the text analysis. So what else Lucene provides us? So Lucene has very many query parsers. So what query parsers does Lucene-grep expose for us? So of course, the default query parser is the classic one. And the classic query parser is the thing when you Google for Lucene query syntax, and the first hit on Google page is about exactly that one. So yeah, so Lucene-grep provides you a flag where you can specify a query parser, you can provide a name for it, and then it knows how to deal with your query. In this case, the trick is that it exposes a fuzzy search. So a text will match if there will be a term that starts with those 5 letters, and then there will be some other letters at the end, as we've seen. And the output of this search with Lucene-grep looks like this one. So all the text is highlighted, which is cool. And other things that the classic query parser exposes is some basic phrase querying functionalities. So you just put your query between quotes, and then the text, for the text to match the query, the terms should go in order there, as we've seen here, and the matching part is highlighted. So that was the classic query parser. Yeah, so there's another query parser available, which is for complex phrase queries. On the surface, it looks kind of similar to the classic query parser, the one that we've seen previously, but phrase queries are much more expressive. For example, when I have text Jonathan John Peterson, and I ask Lucene-grep to search for a phrase, you see those double quotes, for 2 terms, And the first term should be one of these, and this last term is also fuzzy. And then the second term should be this one, where the ending is also fuzzy. So given that text and that query, Lucene-grep highlighted this part as the one that matched the query, despite the fact that this term as a standalone would match this one. Yeah, so that's a complex phrase query parser. There's also a simple query parser available. On the surface, it's also very similar to the classic query parser. But the cool thing is that any errors in query syntax will be ignored, and the parser will do the best it can to do a search without giving you back any errors. For example, if you write such a query for a normal Lucene parser, it will do something unexpected. But here it will interpret this query term as just one term, with a asterisk at the end. And I think that when I was preparing for this presentation, I thought for myself, most likely this should be the default query parser for Lucene-grep. So most likely in the next release it will be so, because there were people complaining that Lucene-grep is not very forgiving when you want to do something more advanced. So yeah, there is also a standard query parser, which implements the same thing as the classic query parser. And I do believe that there should be a reason why it is in the default Lucene distribution. But well, I don't know the reason. Most likely it's a showcase for this flexible query parser framework. And then there's the last one, the interesting one, the surround query parser. And the queries here look a bit different. So you just for surround queries, you're saying that within two terms here that must appear in order, and those two terms are Lucene and awesome. For the text to match, it has to satisfy this criteria. And yes, and it works exactly as expected. So there's a Lucene, one term in between, then the second term is awesome, and the query matches. So we have highlights. But if the order of your query terms is not important, you can just substitute this W with an N, as you see here, and then you can search in this way, like awesome and another term Lucene, and the string still matches. However, I would warn you before using the surround query parser, and the warning is that the query terms, those two little friends, are not analyzed before querying the text. Meaning that if you configured your analyzer to, for example, to stem this text string, then these two will not be stemmed, and the full strings will be used to search here. So you might have a hard time, as I did, while figuring out how this surround query parser works. Yeah, so this was about the query analyzers, and yeah, there's another cool trick I promised you to tell about. It was the only analyze flag. So the only analyze instructs Lucene-grep to only apply the text analyzer on the input string and output the list of tokens for each input string. So how this looks in practice. So if you say provide a only analyze flag to Lucene-grep, given a text, Lucene-grep outputs you a list of tokens. So by default, it lowercase, split the string with the standard tokenizer, etc. And you have a nice list of tokens that you can observe. Imagine if you have stop words, the stop word would disappear from such a list, and so on. So that's a very basic example. Yeah. So what other cool tricks this only analyze flag provides us? As I mentioned before, I'm kind of proud of the custom text analysis pipeline setup. So, for example, in this example here, we have a quite involved text analysis pipeline. where I have a couple of char filters, I have a tokenizer, and I have a token filter. So how come that this little piece of HTML, you see those P tags, was turned into those three terms there, bar, and buzz, like foo, bar, buzz. Like how come this happened? And when you look at the text analysis pipeline, everything goes in that direction. So first the HTML tags were stripped out, then the pattern replace char filter was applied. So the foo, this thing was replaced by this one. It was tokenized, and then this S ending was dropped because English minimal stemmer took care of that part, and everything was uppercased. So if you want to learn how the various text analyzers in Lucene work, I think it's pretty neat approach to have a look. And what's another trick that only Analyze provides us is that if you also specify the explain flag, the output of only Analyze will look somewhat similar to Elasticsearch's Analyze API, meaning that it will output the token, the position length, and other attributes of your tokens. However, when comparing to Elasticsearch's Analyze API, this Lucene-grep, I would say, does the job better, because there is no need to recreate an index on every custom analyzer change. Because when you change something there, you have to delete index, create index, then query with the field. So there is no such hassle here. So yeah, I like that. And also for the future work, what I most likely will try to implement, and not that far in the future, I will output the tokens as an input compatible for the GraphWiz library. And why to do that? Because I would like to see the token list, which is actually a token graph, as a graph, drawn as a graph. So I took this nice picture from some internet blog. So most likely I will implement this in the near future. Yeah, cool. So we are done with this only analyze flag. Another cool trick that Lucene-grep knows how to do is to run multiple queries on the same string. So how to do that? You can provide a queries file, a simple JSON queries file, where we have an array of queries, where every query has its own ID. It has its own Lucene query, where you can specify also the Lucene query parser and also the analysis pipeline. In this case, it just specifies that the stemmer is German, because the query is German word Hund. In English, it's a dog. And then there is another query for English language, dog, and it uses English stemmer. And the output is as expected, as we've seen in those previous slides. So you can imagine that this list can get pretty big. So I want to assure you that Lucene-grep, when started, loads all the queries only once. So it prepares them, and that's it. The queries are not touched anymore. So on my laptop, I ran a little experiment. So I took a bunch of city names from the GeoNames database. It was around 100,000 queries similar to these, and it took about 1 second to load it on my laptop and run the search at the same time. So I consider the performance to be pretty good. So that's a neat trick. And why would you want to have a query file? Imagine that you have a use case where you have you want to percolate your document against some registered things, like for spammy things, for person names, and stuff like this. So you just prepare a queries file of this format, and Lucene-grep knows how to work with it. So that's why you would need loading queries from file. Yeah. And of course, Lucene is famous for being able to run full text search. So, for example, here I did a little demo where I created two files, Lucene.txt and grep.txt, where I have such strings, and I asked Lucene-grep to search for Lucene string in all the files that has that .txt ending. And it found the Lucene.txt file, this one, in the first line, like it was first line, and it highlighted this thing. So it's kind of a full text search. So what else? So that was a very simplistic example. But what if you have the same files, pretty much the same files, but you want to run your search and get the output sorted by relevance, meaning that you have to score the document some way. So Lucene-grep provides you a flag that asks Lucene to compute also the score of a particular document of that file. And then, since it doesn't have any, let's say, built-in capabilities to holistically evaluate the the relevance and the sort by relevance the separate strings, I just asked JQ. Well, first of all, I had to mention that the output format is JSON for this particular example. And when the output comes, I asked JQ to sort the JSON documents by a score attribute. Then I ask TAC program, which just reverses the list of whatever comes there. I take the top 3 documents, and I ask JQ once again to pretty print the result. And here we go. So we have the most relevant of those two files, the one that has Lucene mentioned 2 times. And therefore, the score is higher than the document where the Lucene is mentioned 1 time. Where it was Lucene. So as expected. So it's kind of a search on your file system without indexing anything into your Elasticsearch. So for some use cases, it might be nice. Yeah, so full text search. So, okay, so let's talk about a couple of use cases that I myself I'm using Lucene-grep for, and some people on the internet were complaining to me about why Lucene-grep doesn't work for their use case. So one thing that I was trying to do, so I implemented a little source code search. So when I code, let's say in Python or in Java, I write my source code, and then I don't want to open IntelliJ because it's slow to open. I just want to search for a class, let's say, and I want to search by class name, but I do not remember how this class name was typed. Let's say it's an artificial example. So my class name is my full class, and if I let's say apply the word delimiter graph filter on this class name, I get 3 tokens, my full class, and then you can imagine that if my full text search query is just my full, and then it will find this file where my full is present, and I can type my full as like 2 separate words, for example. And if I enable scoring, as we've seen in the previous example, the files will come back in the order of their relevance, which is nice. And then if I ask the Lucene-grep to output the file names as hyperlinks that are pointing to the file in the terminal emulator for a specific line in that file, because Lucene-grep knows which line matched. I can just click on that link, and then my text editor opens up exactly in the place where I've been searching for it. So, and since you can come up with various text analyzers, you can come up with one for your language of choice for your source code. Also, what Lucene-grep might be a good alternative for is for Elasticsearch Percolator. How it could replace it. So instead of starting Elasticsearch cluster that listens on some HTTP port, you can just start Lucene-grep with an open std in, std out, and stdr pipes for interprocess communication from whatever programming language you're using. For example, here I used a little Ruby example that did exactly that. So of course I use some library. Then I asked this library to open a process. Imagine this is the shell script to start Lucene-grep process that will search for Lucene string. And this library provides me all those pipes there. And when I put a string to std in, I can listen on the output on the std out for any feedback. For that little case, of course, when Lucene-grep finds nothing, it must provide something, so it will return an empty string as a denominator for I haven't found anything. But for the full example, which I showed for my colleagues, since I'm working for Vinted, where most of the developers are Ruby developers, so if you go to the Lucene-grep repo, you will find the full example here there. Yeah, so yeah, that was pretty much what I wanted to tell you about what Lucene-grep can do now. And what about the future work? Of course, since I'm an enthusiast of open source, the first things I take on are your issues that I found in the Git repo under issues. So if you used it, if something doesn't work or you want something some cool stuff to be implemented, just ping me there. But the very thing that I would like to implement now, I would like to implement a mechanism for shared analysis components, meaning that I would like to specify analyzer once, and for every queries, most likely in the query file, I would like to use a reference to that analyzer instead of asking to inline the text analysis config with every query. So that would be a nice addition. Also, I think that it would be cool to have a home of Lucene-grep on your machine, where you would keep all the resources in one place. For example, if you have a stopwords token filter configured, and as you know, the stopwords file is a file, so why not put that stopwords file under Lucene-grep home and use it from there. Also, as I mentioned before, I would like to release the analyzer construction code as a standalone library. So that would, I think, ease the creation of Lucene analyzers. Since I'm a software engineer, I would like to work on melting your CPUs. Lucene-grep, as it is now, it's pretty fast. On my laptop, it is able to search in 1 GB of text in just under 10 seconds. So it's fast, but it's a single core execution as of now. So what I would like to do, I would like to use all your CPU cores at the maximum level for the shortest amount of time possible to do the job. So, but that, however, most likely will require me to stop preserving the input order, because for now, whatever was the input order of lines of text, the response will be in the same order as it was from the input. So yeah, and as I mentioned before, not all the text analysis components provided by Lucene are supported. So I would like to add a couple of more neat token filters. For example, a token filter that allows to inline the stopword list and would not require a file there. So basically, these are the directions on what I would like to work on in the future.